Today we're going to talk about section 10.4, and in section 10.4 we're going to be multiplying polynomials. As we're going through this section, we will be using our product rule that we talked about in section 10.1. So remember, if we're multiplying any non-zero base, and our bases have to be the same, so same variable, we can add our exponents. Right? So we're not going to change our base, but we're going to add our exponents. So to start with, as we're going through these multiplication problems, we're going to start with simple problems and work our way up to more complicated ones with more terms. So we're going to start with just multiplying two monomials by each other. Remember, a monomial is a polynomial that has exactly one term. So as we're going through this, what we're going to do is we're going to multiply our numerical coefficients out front, and then we are going to add the exponents of the common variables. Right? So as we're going through these, again, we're thinking about this as multiplying our coefficients, and then we're going to use that product rule to add those exponents. So there's just a little example that's illustrated here. Right? So we have 3x squared times 4x cubed. So 3x squared is this 3 times x times x. Our 4x cubed, 4 times x times x times x. Okay. Then looking at these, the 3 and our x squared are those first two x's. Then we have that 4 and our other 3 x's. Right? And using our associative and commutative properties, right, that gives us a way to multiply our numerical coefficients together, group them together, right? So we're using our associative and commutative properties because we're rearranging the order, we're regrouping these things. So we group our numerical coefficients together, our 3 times 4 gives us 12, and then we group our variables together, and that gives us an x to the 5th. All right, so we're going to work through some examples here. And we're going to be multiplying two monomials. So we have 2m squared times 8m to the 4th. Right, so we're going to start with our numerical factors, coefficients out front. 2 times 8 is 16. And then we're going to add our exponents. Right, 2 plus 4 gives us 6. So we have 16m to the 6th. For b, we have negative 9p fifth to the 5th times p squared. Right, there's an invisible 1 in front of this p squared. Negative 9 times 1 is still negative 9. And then we're going to add our exponents on our variable. We're going to get p to the 7th power. For c, negative 4 times negative 3. Right, negative 4 times negative 3 is going to give us positive 12. Then we're going to add our exponents. We have an invisible 1 on this y. Again, if you want to write it in there to help, you can. Right, so 1 plus 4 is going to give us y to the 5th. And then last but not least for d, a positive w times a negative w, well, that's going to give us a negative w. Right? Again, there's invisible 1s as coefficients out front. Add our exponents, an invisible 1 plus that 5 is going to give us a negative w to the 6th. Right, the other case where we're going to see multiplying monomials together is we could simply be squaring our monomials. Right? So we'll go ahead and work through example 2 because we're still multiplying monomials times each other. Right? The only difference is it's written slightly differently because we're multiplying the same thing times itself. Right? So for example A, 5a cubed squared. Well, that's really 5a cubed times 5a cubed. Right. So 5 times 5 gives us 25. Right. We add our exponents, we get a to the 6th. Right. The other way we could think about this, we could go back and use our power of a power rule. We square 5, we square our a to the 3rd power, or a cubed. So there's kind of different ways of working through it. But I think the easiest way is just to write it out as two monomial terms, so that way we can do it just like we did the previous example. Right. So for b, we have 8m times 8m. 8 times 8 is 64. M times m, we add those invisible ones to give us m squared. Right. we have negative 9x to the 5th times negative 9x to the 5th. Negative 9 times negative 9 gives us positive 81. 5 plus 5 gives us an exponent of 10, so we have 81x to the 10th. All right, so when multiplying monomials, remember we are multiplying our numerical coefficient out front, and then we are adding our exponents of our two different monomials.